All right. Hello, everyone, and happy Friday. Thank you all for taking the time out of your day to join our webinar. Today, we will explore how StepWin promotes good building science principles in residential construction projects, followed by a live demonstration at the end. My name is Kayla, and I'm in charge of the business development and outreach of Lambda Science. Today, I will be monitoring the chat, so please, if you have any questions, make sure you put it in the chat box, and we will be answering all your questions at the end of the webinar. To introduce the rest of the team, we will start with Sahand, and then lastly, Armand.
Hi everyone, my name is Sahand and I'm the technical lead at Lambda Science. And Arman, if you would like.
Hello, everyone. My name is Arman. I'm the CEO of Lambda Science. Kayla, if that's okay, I'm just going to get started with the presentation.
Mhm.
Perfect. Okay. First of all, I'm going to share my screen. Thank you all for being here. This is such a great opportunity to talk about the work that we have been doing. More importantly, this is one of our record-breaking webinars. We have so many people here, and it really shows the interest out there to perform exceedingly better and gradually better in the construction sector. As we all know, the construction sector is taking a front seat in our path towards a sustainable future for our province, our country, and our planet. So thank you all for being here. We are really excited to talk about what we have been doing over the past 3 years. So many of you may know that our software, StepWin, is here to promote good building science. We give builders the ability to find more energy efficient designs without an impact on their budget. And as you know, so far, StepWin has been available in 5 cities across British Columbia. So one of the important pieces here is that we are working really hard to expand to new regions. But today's conversation is really more about what sort of insights we have gotten out of StepWin. When we put in a design into the software, we give it different wall assemblies or components of the building and also the dimensions. And then StepWin helps us identify and find what design is performing best with the energy efficiency of the building. But what we do on top of it is going back into the results and see what really has worked there that is making a design shine amongst the others. And that is the conversation we are going to have today. So today we are going to start with a quick overview of our past webinars. We are going to talk about some of the highlights of them. We are also going to talk about the trends that we saw, the stuff that we are thinking is going to overall create better designs. We're also going to talk about StepWin as a tool. And a tool is what it is. It's just a tool. So it shouldn't be relied on blindly. It's important that we keep in mind what are the pieces that need to be kept as due diligence by the builder or the people who are working on building projects to make sure that the real world building that is being constructed is going to perform well to what the audience, what the occupant needs. Finally, we are going to hand it to Sahand so that he can go over design iteration with StepWin, show us how the design is put in and how are we getting the results. Finally, we are going to answer your questions. We welcome you to ask your questions in the chat bar on the YouTube video. Kayla is going to be monitoring the chat, and we will have an opportunity in the end to go over them and answer any questions you may have. So let's get to it. April webinar, we talked about the shift we are having in the building energy efficiency. Previously, the design processes used to look at different components in the building separately. So if you had the skylights and shafts and ceilings and you had walls, they used to look at all of these things separately, come up with different proper insulation levels and design considerations, and try to improve the building on a per part basis. But what we learned along the way was that the buildings work as a system. So the system is not going to perform well if the components of it are not harmonized together. So we are now looking at this building as a whole with the performance-based energy efficiency regulations that are popping up all around the world. In BC, we have the BC Energy Step Code, which is a prime example of how this being implemented across the globe. We also provided an example of a house that on the left, we have a house that has over insulation along the roof. It doesn't have great insulation considerations along the other parts. Some parts are neglected, and as a result, you get a design that overall performs really poor, but it's going to cost a lot because of all of that over insulation. On the right, you are seeing another building that has all of the right parts, all of the right pieces, overall a harmonized level of energy efficiency across all of the components, and the building works as a system. So you are going to get high performance for lower cost. If that doesn't make a lot of sense, think about the building envelope being a bucket and energy inside it being water inside that bucket. If you have a leak in the bucket, thickening the wall of the bucket doesn't do anything as long as you are not plugging the holes and stopping that water from escaping. The same thing applies to the buildings. If you have the path of heat, least resistance for the heat, for example, if you have windows that are letting all the heat go outside, it's not going to perform well if you over insulate other parts. The real solution is focusing on those leaks and try to maintain the energy efficiency through the weakest parts. We also provided the example of Sahand, my colleague, who, when he was a builder, let's say we imagine he has 3 window choices from different manufacturers and different options that he have been presented with. And based on the properties of them, one of them is going to cost more for higher performance. Now, when we are looking at the buildings on a per component basis, the issue we are going to have is that the performance is going to not really show itself, and when we are trying to reduce the cost on a per assembly basis, we may not get the overall best system. With the performance-based regulations, you will see that the builder goes on a very different path for any of these window choices. So somewhat counterintuitively, if you pick up a higher performance window and we look at different assembly configurations, we may see that the window that costed more in the beginning is going to actually, in the end, stop some of the over expenditure and start saving money. So again, going back to that example of the bucket, we are going to have address the leaks in the bucket and make sure all of the energy is staying in. So moving on, when we have the typical construction project, the windows in the example we provided that Sahand had is not the only issue that we're going to be faced with. There's going to be a lot of choices that the builder is going to be facing with, and finding the overall best system is not going to be easy. So that's where StepWin really shines. We get all of the options that a project has. We also get the design considerations for the project, including different dimensions, different assemblies and systems that are going inside the house, where it's located, the climate data, and all of that. We put these through costing and energy efficiency analysis and beyond, and we find the system that works best for the builder. And we talked about how the energy efficiency with this new system cannot be an afterthought. More than just providing a software, we are providing a shift in the way the project is being approached. When you put energy efficiency first, you are opening your path to a lot more cost-saving opportunities. We also talked about how the energy efficiency in the project cannot be based on the choices made on intuition, recommendations, or guesses of the project. It needs to be scientific. So if you want to learn more about any of these subjects, any of these titles, please feel free to go to our YouTube channel, where we have the recording of the past webinar, and we talk about these points in detail. Now, in this webinar, we are going to talk about our experience with high-performance construction. Again, going back to a building, imagine this being a cross-section of a design done. So the place of windows, the place of different assemblies is based on what sort of spaces are going to be provided around the house, what sort of scenery is around the place, what sort of privacy considerations are there. So let's imagine that all of them have been came up with, and now we have an opportunity to go in and find what sort of assemblies do we want to put inside this building. Well, as the example we provided, if you're faced with 3 options for your walls, 2 options for your windows, 2 options for example, the hot water boiler, and then extend these options to everywhere else around the house, it really quickly becomes way too many options, because we cannot, as we said, we cannot assess these options individually. We have to look at them in combination with other systems, and we have to go over every single possible combination of these options. So even with a small number of different assemblies and different mechanical systems around the house, you will end up with tens of thousands of cases. And the BCS Step Code Metrics study is a really good source of talking about this issue. So if you want to learn more about it, please go there. But let's say we have 20,000 possible options that is going to be all of the valid combinations of these different systems. Now, previously, we were not really able to go through all of this one by one. So a StepWin as a solution comes in, and it has the capacity of looking at all of these design considerations and find the best one. Now, the first thing a StepWin will do is going to make all of the combinations of the designs. It's going to perform energy simulation on them and also costing analysis. And based on the result of those, as well as other metrics such as GHG emissions, it is going to give you what is a design that is performing as the best bang for the buck, which one has the lowest cost, and is going to present you out of that 20,000 with a cherry-picked set of maybe a handful of designs that you can choose between based on your other priorities. Over the course of the 3 years that we have done this work with a StepWin, we have had over 3 million design possibilities for all of the houses that we have done overall when we sum them up. And today's webinar is about that. Is about what makes good buildings, what trends we have seen in these over 3 million designs that we've had. So let's jump into it and let's talk about the first thing we have noticed, and that is there are no silver bullets. In other words, not one system is going to solve all of the problems. When you go and talk to salespeople or go to the company websites, you will see that the products they have out there, it has a lot, sometimes certifications, sometimes they have awards coming in, they have acknowledgements, and they put all of this information in, and the salespeople are going to give you this rosy picture that that is going to solve all of your problems. In reality, these systems, each of them, depending on the level of efficiency they have, depending on sort of performance and costing they provide, are going to shine in a certain place and not everywhere. So the most important thing to think about is that perhaps a lot of these choices that we may get comfortable with may have their place in particular designs, but then they don't stay relevant all the time. If I want to highlight one particular thing that we think is typically overlooked is the window performance. And I was present at I was the guest at the Tech Talk by the Fenestration Canada on May 7th. So if you want to know more about that subject, I invite you to go to their YouTube channel. It was a very good conversation there where we were talking about triple glazed windows. But as much as I like to extend this and say that that has always been the case with all of the assemblies, like one particular mechanical system or envelope we have found, that is not the case. But you have heard from us in this webinar and before that keeping the envelope uniform, thinking about that system as a whole is very important, and that's really the key to come up with good designs. So in this example, imagine you have just a corner of one of the rooms we are talking about. We have this wall, so there is a window penetration, there's a door penetration. It's good to think about what those penetrations are doing, going back to that water and the bucket example, and try to improve those penetrations in the first place, rather than doing what we are familiar with or extending insulation in the places that we already think that they have a lot of attention given to. So the main energy efficiency drivers, the way we have been separating them, is building envelope and mechanical system. So building envelope is the shell of the building, just like the wall and the window and the door we just talked about. And the mechanical system is those more active elements that are going to compensate for the heat loss in the passive elements, which is the building envelope. Now, it's important to keep in mind that sometimes this conversation about what is the energy efficiency driver gets in the direction of mechanical systems. So we have that sort of attention towards really high energy efficiency systems such as heat pumps or ultra efficiency systems, and they seem like a solution that should be given priority to. But in reality, building envelope should be given the priority. And I cannot stress this enough, the most efficient mechanical system is the one that never turns on. Keep that in mind, that if we are not having a building envelope system that is losing a lot of heat, a lot of energy, then we don't need to have the systems that are going to constantly compensate for the lost energy. And lastly, another trend that we see and we think is also very important in terms of coming up with the overall good design is airtightness. And airtightness is the controlled air movement inside the building. I want to put emphasis on the controlled air movement and uncontrolled air movement, and we are going to come back to that. So imagine that you have done the right building envelope design. We have put all of the right insulations in all of the right places, but you haven't done a really good job of sealing these systems together. So when a cold wind is coming in, the high performance window and the high performance wall have a gap, and all of the cold air just bypasses them and comes in. Well, that will not only render all of these systems useless, it's also going to make sure that your mechanical systems are going to overdo a lot of things just to compensate for the amount of lost heat because of this air movement. So it's very important for us to also seal all of these gaps between these high performance systems and make sure that the hot air or the cool air is going to stay where we want it to stay. Now, the important thing, again, comes to uncontrolled air movement. We are talking about the sort of air movement that is happening between the cracks and the leaks, the sort of air movement that can actually have a lot of problems with it going around these assemblies and picking up mold and all of that. We're not talking about people suffocating inside the house. When we have an airtight building, then we can really work on heat recovery systems, the sort of ventilations that bring fresh air in, but also harvest some of the heat from the outgoing polluted air and put it back into that fresh air, so we are saving energy. When we are also thinking about controlling the air movement inside the house, we have the opportunity to filter the air, to improve the occupant ventilation rates by making sure that they are getting enough fresh air that they need. So airtightness might not be the most descriptive name here. Maybe controlling the air movement would be a better way to put it. So to summarize our points, the three major things that we have seen, the three major trends we have seen is having an open mind and wide range of possibilities in the design. That's the first thing. The second thing is keeping the envelope uniform. And last but not least, really thinking about airtightness and working on that airtightness. But as I mentioned in the beginning, it's important to also not blindly follow the tool and think about what these are going to translate to on the job site. And the first thing I want to talk about, somewhat counterintuitively, somewhat paradoxically, is that airtightness is just not a number. So we talked about how airtightness is very important, and the way airtightness is tested inside a building, as you know, in the new constructions, you have your energy advisor coming in, putting this system on one of your doors, sealing all of the holes, turning off the fan, making sure that this fan is inflating inside the house or deflating it, and see how much air is escaping from the house based on the fan data. Now, this means that a high air tightness home is basically going to be like a balloon. Like every possible path of heat escape, air escape is going to be stopped. And this is going to get very challenging when you have all of these membranes inside the house and you want to tape between them, and a small wrinkle in one of those membranes is going to penalize the amount of air tightness you will have, because the air is gonna start escaping from there. So having experience iterating over what is making a high airtightness home and having that tried out in multiple projects is the way that a lot of builders are talking about achieving high airtightness houses. The other thing that the energy models may miss is joints and seams that may need some thinking. So, for example, inside the StepWin, you see this wall assembly showing that somewhere that there are no penetrations, there are no joints or no systems. But really, when there is a corner, for example, in that wall, then there is a window coming and sitting on top of that wall, how is that transition is going to work out? When you look at the typical home out there, there's going to be a lot of ins and outs. There's going to be a lot of these transitions between different parts of the building, and even the position compared to the insulation that the window is placing on top of is going to be an important place to think about how the air is escaping. And we really encourage you to talk with your energy advisor, building envelope consultant, to think about what the energy model, or basically a step code performance-based design requirements, consider and what they have in their modeling procedure, and what things are standardized and may not be inside their scope. And inside the building project, go above and beyond by considering those in the construction project. One of the really good resources about these sorts of transitions and basically like thinking about these systems holistically, if you go to Hamid Design Build, Hamid is a guy that I learned a lot of these things from. HamidDesignBuild.com, the website has a blog section with a lot of great information with regards to these considerations, some thermal modelings, and really talking about what makes an overall high performance building. And if you have been in one of Hamid's sessions around the province, you know how he has a way of explaining all of these ideas very intuitively. So that's one of the great resources that you can refer to, and have that as one of the resources moving beyond the modeling and going into the practicalities. Energy models sometimes consider some of the things such as the joints, the headers, and other things, but the heat transfer is much more complicated than that all the time. So in some of the existing buildings, when you pick up a thermal camera, you're pointing it at different parts of the building, you will get an appreciation for how much detailing matters in terms of how the heat escapes. So going from that ideal world of energy modeling and bringing it into practicalities is going to need your attention. And that's what our second point was basically dedicated to, the joints and the seams. Now let's talk about the metrics, the BCS step code metrics, the sort of results that the energy models will tell you, and basically in general performance-based construction. It's really important to keep in mind that all of these are modeling. And if you know the famous statistician George Box, he has a famous quote that says, all models are wrong, but some are useful. And building energy modeling is also one of those things that we have this ideal condition. A lot of things have been taken away because we want to standardize the procedure and have a benchmark to compare different houses with each other. And that means that the energy model has a finite scope. So when we are talking about energy efficiency, it's very important to see what the model is considering and what it is missing. For example, imagine you have a solar heat gain that you want to introduce inside your house, and therefore make it easier to heat up and give less work to your mechanical system. And you can do that using low solar heat gain windows. Do that by inviting the sun in through overhangs or different systems. But what your energy modeling may miss is not the house itself, but what is around the house. So perhaps you have some of these trees popping up around the house, that you have it around the house, and what is going to happen is that they are going to stop a lot of this heat gain from coming in. So bringing the world of modeling into the world of realities needs those considerations as well, that where we are building, does the energy model, does our standard really consider all of these things? And if it doesn't, what does it mean for the occupants? Are we going to give them less than expected solar heat gain, for example, or comfort that this might create? Or are we going to do something in the project, going to think about this from the start to finish and address those differences? Another thing is the future. So the standards are meant to consider the future to some extent, but as we know, our country is getting warmer more than the rest of the planet. The planet overall is getting warmer. And I think this graph really shows it in a very tangible way, courtesy of BC Housing, that the sort of temperatures we are going to see within our province are going to be very different in the far future. And just in a couple of decades, we are going to have places that typically don't see temperatures above 30 degrees Celsius are going to see it for weeks. And considering that inside the lifespan of the building is very important, even though we are doing the modeling for today. The other thing is occupant behavior, and rightfully the models, the standards keep this outside. They consider the same and ideal occupant for every building that is being going through these regulation procedures, such as the STEP code, and they don't make an adjustment based on what sort of occupants are inside the houses. I think it's important to keep in mind that people use buildings differently, and educating them about what is the right way of going about the using their building, just like all of the other equipments that they have in their lives, is going to be very important. So the photos you see on this screen is coming from my balcony on the last year where it snowed in Vancouver. So the first one you see actually all of these penetrations causing a lot of snow to melt. That means that the heat is escaping from that place a lot. But the photo at the bottom is a few days after that. And I want to point your attention towards these sloped roofs at the front. You see one of them still has the snow on top of it, and the other one has all of the snow melted. And these are two separate units. So one of them presumably have been using more heating, or basically using the space differently. And that's going to make a difference in what the occupant is needing and wanting. And this goes both ways. We have to make sure that the occupants are educated about all of these ideas that we have about high performance buildings, and there is no miscommunication there about what is translating to actually high performance and healthy building environment, and make sure that they are not trying to fight it in some way. So to summarize, we have three major things that we have seen over these 3 years. High performance buildings are seeing all the time. The first one is keeping a broad range of options. The second one, keeping the envelope uniform. Third one, looking at air tightness. But in the meantime, the translation of these principles in building science, the principles that I think a lot of people have seen, I have seen when I was studying building science, the manifestation of these ones is going to successfully go in a project if we consider the realities of construction, make sure that we are prepared for putting all of these ideas into practice, and also understand that the metrics that we are working with are not complete, and you need to have a whole picture by thinking critically about the construction process. So now we get to the part that we are going to talk about StepWin. So a builder out there, imagine, is having a new build, learned about all of these principles, understands that these are going to create a good foundation for the design. Now they have a number of choices for their project, and they want to see what combination of these choices for their particular project, with all of the design that is done, albeit in the earliest stage, is going to translate into an energy efficient system, and what budget they are going to save by finding that best system. Now, all of the climate assemblies and also design dimensions need to be in play, and that's where StepWin shines. So I'm going to hand it to Sahan to talk about StepWin in one example case that the builder has gotten access to the software, is having a project he's willing to build, and is using a StepWin to really come up with that good design. So Sahan, you can please take it from here.
Hi everyone again, and I'll be demoing our website. So, all right, I think I should be good here. All right, so the first step would be to go to our lambda. Sorry, lambda. Lambda.science website and log into StepWin. Here we need to sign up, or since I'm already signed up, we just log into our app. And the first page is our introductory video about the website. And after this, we move on to our climate page. Here we ask for your construction site address. From this, we get our climate files, and our software will use that. For the second page is the general shape of your building. This specific case project is a 2-story building. It could be 1-story or 3-story. And below that, we have our roof types. I know there are many different types of roof types, but we have divided into 4 types. If you hover over to the I sign, you'll see how we are defining these roofs, and you can use that. So in this case, we have heap and cathedral. You can have any combination of these roofs. You could have flat and gable, flat and heap, or any combination of them, and we will accept that. Below that, we have our foundation. In this case, we only have basement. A lot of times we have basement and crawl space together, or slab on grade and crawl space, or slab on grade and basement. So, but in this case, we only have basement. Since we have a cathedral roof, we're going to be asked for the total building volume, the heated volume of the house. And in this house is around 1,000 cubic meters, or 3,500 cubic feet of air. Below that is our exposed flooring and our cantilevered flooring. And these are, again, if you're unfamiliar with our definition, please hover to our I sign, and we have a description of these. And you can click on this, and it will take you to a video that's Arman's explaining them. And below this here, again, we have our adjusted unheated spaces. And these are your unheated storage or garages that are right to your next to your living space and your living walls, basically. And again, if you're unsure of the definition, please use these for how we're defining these variables. The step after this is our roof assemblies. We have our interior installation and exterior install assembly for cathedral roofs. These are 2 default assemblies. We are just providing this as a reference. You can add your own here. Give it its name, R value, material cost, and labor cost. And our software, we use this as an optimization for the best performance, thermal performance in terms of cost as well. So, and if you don't like any of ours, you can just deselect ours and use yours. but in this case, I'm just going to keep ours. And since we have a cathedral roof, we have our skylights here, and we have an option for different type of skylights, if they can open or not, and their directions and their dimensions. If we had flat roof as well, we would have an option for skylights here. And below that, we have our attic roof details. Again, these are two details, and if you want, you can add your own details and deselect ours or keep ours. And so, for example, by this point, our software have four combination of different roofs and design styles. So two for attic and two for cathedral roof. This page is the main floors of the building, basically, your main floor, second floor, and if you have the third floor. The first part is your wall assemblies, and these are four defaults we have. I've personally used many more different styles of assembly, so I would just add those as many as you like and deselect ours if you don't like them and you don't agree with our pricing. And below that, we have our floors dimensions, our areas and perimeters and wall height. Keep in mind our perimeters are measured from inside of the wall and do not include the distance or the distance of your adjusted unheated space if you have any, because that would be considered, would be calculated for that area. And your wall height is, I know some of the walls are like could have variable heights in new houses. So this is your average wall height. Um, you do the same thing for the second floor, and if we had a third floor, we would do the same for that as well. Fenestrations, all the openings, so anything from your patio door, your windows, and your entrance doors, and you would just input the dimensions, the direction they are, and the number of them, and you can select their different types here. So if they are hinged, they're slide, all sort of variety. In this step, we're going to be inputting the amount of foundation concrete wall that is exposed to the air and in the soil. And if you have any pony wall, and this is the pony wall that's out of the soil on top of your foundation wall, you would input that area here as well. Below this, we have your slab details, and again, we have provided five designs. Feel free to add your own. Here we are inputting our wall assembly for basement wall assembly. These are your concrete walls. And we are providing an option to have installation inside and outside, so you can choose how you want to insulate these. And feel free to, again, add your own insulation and or your style and what kind of insulation you want inside and outside of your concrete foundation wall. And below this section, we have the openings for our basement. So you could have, if you had a legal suite, for example, you would have your entrance door, your windows or patio doors here as well. And in this case, we are doing our windows. Windows here, the first part is your framing. So we have double glazed PVC, double glazed wood, triple glazed PVC, and triple glazed wood. We have our glass coatings, and they are from very high solar heat gain to very low solar heat gain. And so clear to tinted, and you can select these and see the defects under your design. The next step is our mechanical systems. And again, these are anything from your heat pump to your air conditioner to your HRV, your furnace, baseboard, they're all here. And you can select any combination of them. The only limitation is that you need to at least select one from each row. And so, for example, if you have no auxiliary system, you just select no, but it needs to be at least one selected. And this step is where we're running our simulation. So this will take a while. The software is going to go through the combination of all the choices we've made. So it could be 20 or 30,000 combinations. So we multiply all the combinations basically together. And our machine learning system will find out the most optimized one for the best performance, thermal performance, and cost. And we're going to rank them by the steps. And I mean, you could also see they're sorted by price as well. Or you could just use the suggested ones. I'm gonna go to the first option here. this specific design is the best performing in step 5. It's been over 17% more thermally efficient compared to an average design, 14% more efficient in terms of mechanical use to an average design. And and this is our first suggestion here, for example, in steps 5. You could also look at step 4, 3, 2 if you just click on these filters. And this step, we have our cost breakdown. Keep in mind, so these are only thermal energy related costs, so only material that related to thermal transfer. So even your wall studs will be considered because they are due thermal bridging, but things your wall facade will not be considered because of the air film insulation. So below this, we have your greenhouse gas emissions. And in this case, it's pretty low. And this is what your energy advisor would be interested, your step code metrics. And this house has very good metrics in terms of TEDI, MUI, TEDI reference, and ERS reference. So very high TEDI reference, very low TEDIs, and very low MUIs here. And below this, we have envelope heat loss, internal gain, and solar gain per month of the year. And you can compare these and see the different houses perform different in different months of the year. And below all of this, we have, for this specific design, the details of walls, roofs, attics, windows, basement, and mechanical system we've chosen. And at the end, we have the cost breakdown. But again, this could be different for every builder, depending the relationship you have with your seller or the region you're from. If you like this design, you can press here and it will download an H2000 file that you can give to your energy advisor or your architect, or you can print the PDF and use that. And if you really like it, you can press the star button and it will save it into memory. Now you want to compare it to a different design in here, or if you want to go, for example, I want to add another window to this house. You go here, add another window, and see the effect on the thermal performance. You can run the software again, select that design, and it will show for comparison page, for example. And or if you just want to compare like in a step 3 house, for example, and see how is this different than that. So you can just select that and it will show up in our comparison sheet. And you can look at the comparison sheets here. You can put your description here, the steps they are, the cost they have, and what sort of material they have. And you can do this iteratively till you get the desired design you have. And Armin, I think I'm done. Thank you,
Wonderful.
guys.
Wonderful. Thanks so much. Okay, so I think at this point of the presentation, Sandy, can stop sharing your screen, and we are going to go for the questions. Kayla, do we have any questions?
Yeah, for sure. We have lots of
Oh,
questions.
okay, that's good.
Perfect. All right. So I grouped the questions all together. Please, just ahead of time, I'm sorry if I butcher your names, but I will try my best. So starting off with the first one, Farsard asked, do you consider green certificates like LEED or LEED in your selection?
Not at this time. I think very important that in the future we have something related to different standards that are coming in inside our system. But right now we are only focusing on what is mandatory for the builders and what sort of mandatory requirements they need to build, just so that there is, first of all, more acceptance of the product. And more importantly, the industry-wide standards haven't really shown themselves in terms of something that everybody is looking at, but there is definitely a lot of room of improvement for those, especially when it comes to some of the metrics that are not by default inside the step code or any sort of mandatory regulations.
Perfect. All right. Thank you. Moving on to Christian. The first question is, I see you can export to HOT 2000, but how complete is the export?
Wonderful question. So the major thing is that sometimes Hot 2000 has some additional documentation features or some of the things that are very specific to the house design that we don't focus on. So the number of inputs you give to the StepWin are in what are the major drivers of energy efficiency and energy consumption that we are focusing on, and the exports that the Hot 2000 file is given is encapsulating all of that. Also, when you have an assembly, for example, for the Windows and whatnot, we sometimes do additional calculations, go into our libraries in the backend, do some of the coefficient analysis, and find the right numbers to put in different fields in Hot 2000. Things like such as highest ceiling and whatnot, we find it based on their help and their guidelines. So we take a lot of that laborious work away. But I want to highlight something very, very important. This is written in our disclaimer. This is written inside when you're signing up. So make sure you go over that when you're signing up. It doesn't take you less than a minute. StepWin is not a replacement for any professional service. So you still need to have your energy advisor really focusing on your design. You still need to have all of the engineers and other people in the project doing their own part. And this is going to be that earliest stages starter of the conversation of integrated design process.
Awesome.
Excuse me.
Thank you. Another question from Christian. Any timeline for availability in Sam and ARM?
Oh, that's a great question. We are working really hard to make expansions right and fast. As you know, there are some moving pieces with bringing the right stakeholders on board. But we will be there hopefully very soon. I mean, the sort of work that Sahand in particular has been doing on a lot of the climates, finding the local data that we need to do is progressing really, really fast. So if you subscribe to our newsletter, we will be sure to give you a heads up when we are there.
Perfect. Another question from Christian.
Yeah.
Does the model provide the TEDI and MEUI numbers for the step code?
Absolutely, yes. Now, keep in mind that the final design that's taken forward by the energy advisor, when you have all of these additional considerations, may change slightly, or depending on the project, it may change. But when we talk about the major energy efficiency drivers and what you will see coming out of that Hot 2000 export, yes, as Sahand showed it to you, you can see it inside the report page. So Sahand, maybe you want to show that piece again, if that's
I'm gonna
okay.
share my screen again.
Mm-hmm.
And yes, so we have all the step code metrics here, and they will change depending on what design you're looking for. And you can select a different steps, and you can see what each specific design has. For example, this design has a TEDI of 28, ME of 38, TEDI reference of 20, and ERS ref of 21, for example. And you can, so basically we have them. Yes, we do have all of them here.
Wonderful. Thanks a lot.
All right.
Thanks, Sahan and Armin. So the R value inputs, self-defined roof, is this nominal or effective? And same for the walls.
Oh, thank you. Great question. These are effective. Make sure that you are considering all of those, additional paths of heat transfer and all of that inside the effective number you are going to put into a StepWin. We are going to rely on your number to do our modeling, and just for the sake of leaving you to the close as possible to what you are actually wanting to do, we don't do any adjustments on that. So effective installation for all of the installations you're doing, and if you hover over that eye icon when you are making an installation, it actually tells you which the effective R value, and also tells you which components we are considering in that R value calculation. And also in the reporting page of a StepWin, we link you to some guides. So these handy guides, if you can show, for example, the R22 Plus. These have really good tables with the R values that are also basis for R calculations as well. If you want to improve something, for example, the wall one should be good, Sahand. I think the R22 Plus.
Yes.
Yeah. Yeah, so we take you to the guide, we take you to the exact page that the guide has shown this wall assembly. If you want to make an adjustment on the second page, there is a good handy sheet that you can use to make your R value adjustments. And these are all around the interface, and you can refer to them as well for your effective R value calculations.
Awesome. Thanks, guys. Thanks, Christian, for all the questions. I hope we answered anything, and please ask any further questions if you need. Moving on to Kim Darwin. Does the software conduct simulations for renovation purposes to assist with the finding of the most energy efficient home improvements?
Wonderful. Yes. Very soon. This is something that we are working on. We have been working on. So if you have caught our latest newsletter, you know that StepWin is now expanding into three simultaneous products: a StepWin House, which is the tried and true interface you just saw; a StepWin Multi for multi-units; and a StepWin Retro, which is for retrofits. And the great thing is that these can work with each other. So for multi-units, we are doing that retrofit as well. These are going to be some small additions to this interface, so you're not going to see a lot of difference. But yes, if you are doing especially a deep retrofit, something that you have access to a lot of things, there is going to be an interface for you very soon. Also, we encourage you to get in touch with us. It may take us a little while until we actually get everything set to go towards that retrofit market. But you know, with the tooling we already have, we may be able to help you do something. So info@lambda.science, that's the place you want to probably contact about it.
Perfect. Awesome. So Tharaka has three questions. The first one is, do you model air tightness in StepWin, and how?
Good question. So yes, air tightness is a part of our modeling in the StepWin. We don't give the choice right now as an input because of that saying that air tightness is not just a number. Moreover, there is a BC government bulletin at the time that came out that was giving certain guidelines to energy advisors to set the air tightness levels at 2.5 or 3.5 depending on the project. Our basis assumption right now is 2.5 ACH. So something that doesn't really penalize the high performance projects, but also has an effect. And in the future, we may actually allow a lot of adjustments in that regard. But just to keep the possibilities in a finite level and allow people to really focus on the major part, and then take that air tightness analysis to their energy advisor. Right now, that is our assumption, which you will also see in our reporting page.
Okay, moving on to the second one. How accurate will our energy modeling results be when we consider different building archetypes compared to the actual building architecture?
Okay, that's great. This is a very interesting topic, and thank you for asking that question. The studies that are being done, which are based on different building archetypes, such as a small, medium-sized, and large buildings, are there to train a builder intuition. And the reality is that the window-to-wall ratios that the studies are considering, that sort of assemblies or basically all of the assumptions they are make inside their archetypes may not really make the exact sort of building that people are actually going to make. And that is where StepWin is bridging the gap, because you are putting the particular numbers for your own project, your own window to wall ratio, and now you are getting that sort of deep insight for a project that you really need. So when it comes to building archetypes, we think that they are staying at the level of training builder intuition, so that the builder doesn't come in with like 10 different walls and 10 different windows, because that's even StepWin is not going to be able to do that thing, as the number of options are going to exponentially go up. So when the builders have the foundation based on that archetype analysis, when their intuition is right, and now they are kind of having that tunnel vision of pinpointing what is the best thing for them, that is where StepWin is really great to bridge the gap between the archetypes studies and the realities that the builders see on their job sites.
Okay, and last question. Are both Part 9 and Part 3 residential buildings considered in StepWin?
So what we are really focusing on right now is a small residential construction. And the small residential constructions are the sort of constructions that are over 90% of the built spaces all across Canada. They are the stuff that over 97% of the builders in British Columbia are doing. And in the meantime, they are the most overlooked sort of building archetypes that have been shown to have a lot of energy consumption based on StatScan data. So as a social purpose organization, our focus in is somewhere that we can reduce our carbon emissions a lot. And that is the small residential pieces in particular. For the larger projects, especially when we go into mid-rises and high-rises, what we see is that the budget of the project allows for dedicated energy modeling firms to come in and do parametric analysis with some of the well-established tools that are already out there. And the need for something AI-driven like what we do may not be immediate. So our roadmap has been focusing on single families for now, and now expanding to duplexes, row homes, fourplexes, and all of those smaller residential constructions. And we will start going, take that path, and eventually go towards larger constructions.
Perfect. Thanks, Armin, for answering, and thanks,
Thank you.
Tharaka, for all the questions. If you have any follow-up questions, let us know. Moving on to Alexis. Alexis has asked, as our energy choices begin to change, transition to more solar, wind, or water energies, how will StepWin or the BC Step Code adapt?
Great question. So one thing you have to consider is that our electrification in BC is very low carbon by default because of going for the hydroelectricity by itself. So electrification on its own can actually be a path towards low carbon usage. As we talked about in this webinar, the most efficient energy efficiency is actually when you don't use energy. So that's what we are trying to promote. We want to make sure that people come up with overall designs that are passive and strong and livable on their own, and really don't need that sort of compensation that comes in based on the electricity or gas that needs to come into the building, even if it's low carbon. In the future of our province, as you have seen in the Clean BC plan, we are having a lot of work being done towards making sure that the energy supply is good, and in the meantime, we are also tying into that demand side. Now, going beyond British Columbia, things are going to be different, of course, because the amount of carbon that's in the electricity is going to be even more. So there is going to be now again another shift for us, that electrification is also not gonna be by default a low carbon path. One more thing I want to add is that one direction we are taking is including the embodied carbon. And this is another dimension that comes into that sustainability aspect of things. When you look at a building and the amount of carbon emissions that goes into creating the sort of materials that create that building in the first place, there is going to be actually almost half of the carbon emissions of the building maybe spent already when the building is built. So we are also taking that a step of making our assessments more holistic by including embodied carbon. But this is, as you know, not a priority for us, as we are only focusing on the stuff that are already mandated and regulated. And the step code is not particularly looking in that area. It's also not particularly looking at the GHG emissions, which we hope that they go in that direction, and we have talked about this a bit in our blog section. So I invite you to look on that a bit more. And sustainable energy is one of my passions. I think for all of us, this is a really important subject. So I would really love to have this conversation going forward. Thank you.
Awesome. Just to kind of follow up, Alexis also asked for part two, sort of what you already just said. But since all the energies produce a surplus, will it change? Will it change to have less energy efficient products in the home in response to consume all the energy produced?
I might not understand the question really well. If my answer is not making sense, please feel free to clarify that. When it comes to net zero and the sort of surpluses we're getting, and if you have been following some of the conversations that have been going with the net zero homes and BC Hydro and purchasing that power, there is a lot of moving parts here, and there is not only a lot of opportunities for people to really have a payback on the work they have been doing, but in the meantime, over reliance on the sort of energy production that can happen on the job site has its own risks. The direction I think that we are taking right now, the goal is to create overall the sort of buildings inside our province that are not going to use a lot of energy in the first place. And the surplus, as we have right now with our electricity that is being produced inside our province, and we are going to have for a while based on BC Hydro's phase 2 reports, there is a possibility that this low carbon emissions is going to go, low carbon electricity can go into other places where they have higher carbon emissions and can help them lower their emissions. So, there is a lot of conversations in the big picture. We typically tend to stay out of that and really try to focus on reducing the amount of energy consumption in a home, which is what we know how to do basically.
Perfect. Thank you. Alexis, if you have any follow-up questions, please let
Yes.
us know. And thanks again for the questions. So Joe has asked, or Joy, Joy has asked, does the model have options for SIP panels?
Oh, that's a great question. We are focusing on the options that are already in the builder guides because of being and having been studied very deeply for our particular climates. SIP systems are, they provide a lot of installation comfort in some of the projects. We don't have them by default. In the future, for sure, we are having some plans to broaden our default material scopes and create interfaces that allow people to have a searchable database of all of the materials that are out there. But the important thing is that when you have the effective R value of these SIP systems, you can use the add new function, which the hand showed, and you can add in your own assembly, and it's just going to work as well. Just make sure that if you are considering our own items inside there, that your costing and our calculation analysis is the same. If you're not sure about that, just turn off all of the wall options or roof options, whatever we have, and put in your options in there based on your R value and cost of material and installation that you have.
Awesome. Thank you for the question. So moving on to Morgan. Morgan has a couple questions for you, actually like 5. So the first one is, first of all, thanks for the webinar. Two
Thank you so much.
questions. First, in the steps in the run results, these are corresponding to the BC Step Code metrics for Part 9 buildings?
Yes. So we particularly focus on Teddy MUI ERS. That is for the Part 9. As you know, in the Part 3, especially the MUI argument, the mechanical energy usage gets more holistic and talks about other sort of energy consumption in the building. So these are particularly Part 9 at the time. Yes.
Awesome. Second, it says that the software is freely available for regions of BC. Do the local municipalities pay for access via climatic data support?
That's a business model. We have we are trying to create a multi-stakeholder model where we can reach different regions as fast as possible, and we are diversifying in that direction. So far, for the next year or so, if you are building in one of those cities, you have StepWin available for you for free. And we are also finding faster and different paths of going all around the province. Make sure that we are creating no-brainer, and cost-saving solutions for people that can easily get on board with, and also the stuff that allows us to keep innovating and keep bringing good solutions to the market.
And just an additional question to the business model, just kind of curious, is setup or is if users for the full version or similar? Just curious how the business model is set up, so the users pay for it, the full version or similar. Yes.
Yes, so we are doing it. We're taking a step in that direction. That if you are seeing the value in a StepWin and you think that your savings have been paying off, you can actually come through one of the resellers or through us directly to use the StepWin in the region that we don't have. Now, the limiting factor right now is the climate data that we need to feed inside the StepWin, and also costing data and stuff that to really make sure out of the box software has a lot of value for the people all across the province. So I invite you to stay tuned to our newsletter. The link is in the description that you can join in there if you haven't already. And there we are going to give you updates about what we have. And very soon, hopefully, we are going to have multiple options that people can use in order to get that savings for their projects.
And lastly, most important, is there a list of current supported regions? Where can they find this,
Yes.
this list?
So right now, the supported regions are the 5 cities we have. The 5 cities, I'm just going to tell them verbally, and I'm going to also show them on my screen really quickly, are in the 3 major regions of BC, which is the Kamloops region. The first one, we have the city of Kamloops. In the Lower Mainland, we have New Westminster and Port Moody. And inside the Okanagan region, we have the city of Kelowna and Penticton. So these are the kind of the dots that are in the region, and now we're kind of expanding from around these and getting new regions coming in all the time. So stay tuned for that. We hate to keep telling people to wait for the solution to come to your region. It's definitely something that we really work hard to get out of the door as soon as possible.
Awesome. Thanks, Arman. And that's all the questions we have right now. Is there
Wonderful.
anything additional that you would like to say? Any comments?
Thank you, Kela. Thank you, Sahand. What a wonderful webinar it was. I hope everyone have enjoyed it. One thing I just want to highlight is that we are starting to work on multi-unit projects. In these 5 cities that we mentioned, we are only doing single-family homes with the StepWin's interface. But please, if you have a multi-unit project, it could be a duplex, it could be a row home, anything. If it's in the earliest stage of the design, please feel free to send us an email, info@lambda.science, which you will also see in our newsletter. And we will help you get on board with our multi-unit work. This is earliest stage of us doing multi-unit systems, but this is basically the next step for us to take. The other thing I want to say is that we have a small ask from you that watching the webinars. We really want to make sure that we are providing the right content and right value for your time and attention. If you can, please answer a survey that we will send you in email after this webinar. That would help us a lot, like much more than it may seem, to make sure that the work we are doing is in the direction that is going to really provide you with value. Other than that, I want to thank all of you for joining us today. Please stay connected with us. Again, you can find the subscription link on our website, lambda.science. Please use StepWin. There is a chat function at the bottom right corner of the screen where you can be chatting with us. If there is any issue arising from your design, we are always there and we would love to help you get the design forward. And in the meantime, find the stuff that may not make sense for new users. Kayla, do we have any questions coming in the meantime?
Yeah, Lori has asked, how
Yeah.
soon Metro Vancouver?
Oh, that's a good question. Very soon. That's all I can say right now. But stay tuned. Yes, very soon.
Yes, and that's
Not
everything.
today, but very soon.
Not soon, hopefully. I know. And everybody, please remember just to subscribe. Our description, or join our link is in the description to join us to our newsletter, which Armin has said repeatedly. So yeah, just please stay tuned, and we're excited to have you guys join our newsletter.
Yeah, thank you, everyone. I think we can say goodbye to everyone, and please stay well.
Stay
Bye-bye.
well, guys. Stay safe and healthy.
Bye.
Bye.